Okay, I welcome to you all to the second lecture of computer organization and architecture. This part is basically within module 1, and the topic we will be covering is bus structure. Okay, so when we discuss about the bus structure, bus is nothing but a collection of wires, okay, that is connecting the various components in a computer. Okay, it can be the CPU, or it can be the memory, or it can be the input output. So there are various components that exist within the computer. Okay, and buses are nothing but the paths which are used to establish some communication between the various types of components, right? Now depending on the type of the signals, the bus structure can be classified into three ways. The first one is the address bus, the second one is the data bus, and the third one is the control bus. Okay, now we will be discussing one after another. Now in the case of address bus, as the name suggests, that it is going to send some address, or it is going to carry some address bits. Okay, now in this structure you can see that this is the CPU, this is the memory, and this is the input output, and there are three main buses. A system bus is known as it is constituting of these three buses: control, address, and data bus. Okay, as a whole, the three buses, it is known as the system bus. So if I say that what is system bus, system bus is the collection of all the three buses which is used in this structure. Okay, it can be the address bus, or control bus, or the data bus, and it is going to communicate with various components. What are the components? CPU, memory, and input output. Now let us come to the system bus. As I was mentioning that what is bus. So bus is a structure, or the path that connects the major computer components. It can be processor, memory, or IO means the input output. Okay, that is collectively known as the system bus. Now this is basically a structure, or the path, which consists of various wires. Okay, now depending on the functionality, it is whether it is carrying some data, or whether it is carrying some address, or whether it is carrying some control signal, the bus is categorized into data bus, address bus, and the control bus. Now the first one we will discuss is data bus. So data bus is the lines that provide a path for moving data among the system modules. Okay, and this is known as the data bus. So what is the size of the bus? It can be 32-bit, or 64-bit, or 128-bit, or even more. So this is known as the width of the data bus. So this, whether it is a 32-bit, or 64-bit, or 128-bit, this specifies that width of the data bus. As I was telling you all that each line, it is nothing but a collection of lines. So as each line can carry one bit at a time, so the number of lines determines how many bits it can be transferred. So definitely if we want to send more data, so definitely if the width of the data bus is more, the performance of the system will improve. Okay, so for example, that if the data bus is 32 bits wide and each instruction is 64-bit long, then processor must access the memory module twice during each instruction cycle. So the total instruction size is this. So I have to fetch the instruction from the memory to the processor, right? So this amount of bit is mainly constituting the instruction. So how many time it is going to fetch? So at a time 32 bit it can carry, so 2 into 30, so 2 times it is going to fetch from the memory module to the processor. Okay. Now next is address bus. As the definition says, that address lines are used to designate the source or destination of the data on the data bus. Okay, so it carries some address. And one thing I missed in the previous case, data bus is bidirectional, whereas the address bus is unidirectional. Unidirectional means it is going to carry only in a single direction, not in both directions. Okay. Now if the processor wishes to read or a word of 8-bit, 16-bit or 32-bit of the data from memory, it puts the address of the desired word in the address line. So maybe if you have a memory location, okay, definitely we have discussed this sort of things in our class also. So if you know that we have a memory, and if you think this is the memory, there are various slots in the memory, and each slot is having a specific address. Okay, now if you see that this is the address is 8000 hex, 8001 hex, like that. So definitely if the processor wishes to read a word of 8-bit or 16-bit or this from memory, it puts the address of the desired word on the address. So whatever is this address, the address bus is going to carry this address. Suppose I want to read some data from here. So suppose it is 52 is the value, hex value. So I will put this address here in the data because I want to read this content. So what is the address location? The address location is 8000. So we are going to put the value 8000 in the address bus. Another important thing is that the width of the address bus, this is very important. The width of the address bus determine the maximum possible memory capacity. Okay. Now suppose if you have the address bus length of we have seen that there are some chip, that is the RAM or a ROM, and if you have some address lines here, so the address lines is suppose A0 to A9. So if you see that there is A0 to A9 means how many what is the width of this? So there should be some dot notation. A0 to A9 means how many bits it can accommodate. So there are 10 bits address bus. Okay, address bus. Now so we can find that the width of the address bus defines the capacity of the memory it is associated with. For example, if the length of the address bus is 16 bits, so very big quantity, 16 bits. So how many possible base? The 16, it is consisting of the 16 0 to 16 1. So how many possible combination? 2 to the power 16 is the possible combination. And if we understand this one, 2 to the power 16 is 2 to the power 6 into 2 to the power 10. 2 to the power 6 is 64. Okay, 2 4 8 16 32 and then 64. So 2 to the power 6 is 64 into 2 to the power 10. 2 to the power 10 is basically the value we are using for this one. Okay, 2 to the power 1024. 1024 is 1 KB. So 64 KB is the value. Similarly, if the address bus length is 32-bit, similarly you can calculate it is the 4 GB address space RAM we can accommodate. Okay, 32-bit. Nowadays modern computers, the 32-bit or 64-bit, that specification is mentioned here. So that is the memory capacity of that particular system if the address bus width is either 16-bit or 32-bit. These are the conventions that we generally use commercially. Okay. Next is last one is the control bus. So control bus carries basically the control signal, whether it's a read, write, different types of enable signals are there. So these signals are generated from the control unit, and to perform some operation, memory read, memory write, these signals are passed through the control bus, and the proper things are basically done so that the necessary action is performed. Okay, so this is all about the different types of bus architecture and different bus structure, and we can utilize this bus when we are designing the system. So thank you all, and